Good morning, everybody, and welcome to our webinar. My name is Warwick Nel. I'm the Operations Director at Geopile Africa. We are driven pile specialists focusing on foundations using driven piles, be that ductile iron or any other driven solution. And joining me today, I've got Nino Welland. Nino is the Director at GCS. And just a bit of background about Nino. He graduated with a BEng Honours in Engineering, Geology and Geotechnics from Portsmouth University in the UK in 1981 and worked for 2 years in Canada before relocating to South Africa. And after working on for various consultancies, he was awarded a GDE in Geotechnical Engineering at Wits University in 1992, and since then has been involved in ground investigations for renewable energy projects in most of the neighboring SADC countries, even as far off as the Ukraine. Realizing the need for renewable energy, Nino formed the GCS Renewable Energy Unit, or REU, in 2018, and incorporated all the specialist studies required for the development of renewable projects, including RAM pile testing and installation provided by Geopal Africa. So I'll just hand over to you now, Nino.
Yeah, glowing report. Thanks a lot, Warwick. And thanks to Dion, especially, and Laura Lee from Geopal Africa for setting this up and driving the whole thing. Warwick and I were talking about the delegate list just now. I just want to go through the delegate list so you know, all of you, who is actually attending, hopefully. You still are attending. But there are some guys that are attending as far away as Kenya and Uganda and even India. So welcome to you guys. And then we have a whole load of local and international consulting engineering firms that we all know, some universities, some contractors even, and even some laboratories. And a few IPPs as well, but no EPCs, which we would like them to also join this webinar, maybe in future ones. And a few students, which is always a good thing to have the youngsters driving, hopefully, in the future, renewable energy. Cool. Dion's going to drive for us. Thank you very much, Dion. Yeah, so from my side, I'll be delivering two presentations, either side of Warwick's presentation on geopiling. And mine will be very quick, high-level, informal presentations, basically. The first one being about 5 minutes, and the second one ending off will be about 10 minutes, so we won't take up too much of your time. But basically, the presentation will be the summary of renewable energy. We can take a quick look at all the systems. Essentially, the photovoltaic, or PV, as it's commonly known, solar farms. That's the most common form of solar energy. And then there are two types of CSP, which is concentrated solar power CSP. And the first one is what I call parabolic trough technology, and the second one is the CSP tower technology. Two slightly different technologies. And then we'll look at wind, but only very, very quickly, because we'll try and do that in a future seminar or webinar. And then not included in this webinar, but I think mentionable, just to keep it all in context, are the other industries involved with renewable. It's hydroelectric power, obviously, and biomass, LNG developments, tidal energy, which is not a big thing here in South Africa, but has been done in Nova Scotia. There's tides of up to 9 meters high, but very difficult to actually develop those kind of energies. And then geothermal, which obviously can be done here, but usually restricted to countries like Iceland. The geology has a big impact on those particular ones. If you have a look at the bottom, you'll see 3 icons: a sun, something that pertains to wind, and then on the right-hand side you'll see the stacks, the smokestacks for fossil-based energy production, and you'll see an arrow there saying the potential decline of that type of development. And that's become, actually, those 3 icons, which I've used in other webinars, has actually become more relevant now, because just this morning, Engineering News article has shown that there are 60 power firms bidding on the latest allocations for the emergency scheme issued from the IPP office from the government. And it shows there that 6.8 gigawatts has been assigned for renewable energy, that's solar and wind, and only 1.5 gigawatts for fossil-based and coal-generated power stations. And that's almost a factor of 5 between the two, so that's very encouraging. Just to start off with the first type of solar power energy plant that can be looked at is the PV, which is photovoltaic solar power plant. And this is just an example, the solar capital development in Ductile in South Africa. And this is the simplest form of solar power energy, and it's done by flat solar panels made from silicon wafers. There's no storage capacity available in this type of development, so it is a little bit restricted. And it obviously takes the direct sun rays, absorption of the sun rays into those panels to form electricity. And the first one of the CSP types is what I call CSP thermal. And this is an aerial shot of the Kashu in Pofadder, which Geopile were involved with the foundation installations. 50,000 piles have been put into the ground there. It took 8 months to install, quite quick for that type of installation. These consist of parabolic troughs or heliostats, some people call them, and they direct the sun's rays and energy onto a receiver that is called a focal line or an absorber tube. This type of development is very reliable and can harness the thermal energy to produce heat and steam to drive a turbine. The third or second type of CSP solar is what I call a tower, CSP tower solar. And this is the Kai Solar 1 Uppington development near Uppington. And the receiver here is not a tube, it's at the top of a 200-meter tower, which is shown in the top left-hand corner there. You might remember in one of the Bond movies, this was the center of one of the scenes in one of the Bond movies. Here, the storage can be done via molten salt tanks. This kind of development is in its infancy and is generally unreliable, but is getting better and more cost-effective also. And in the bottom left-hand side, you'll see a aerial shot of the heart-shaped heliostat field, which for me represents the good health benefits to the planet. And then wind energy, just going to touch on this quickly. That's quite a cute thing from the internet. But generally, wind development in South Africa has huge potential based on the 3,000 kilometers of windy coastline that we have in South Africa. But we'll leave this technology for a future webinar. But suffice to say that Geopile can be influential in the stabilization of some of these mass foundations that are required for these wind turbines. So from me over to Warwick for a more detailed Geopile presentation.
Thanks, Nino. Yeah. Cheers. Thanks a lot. Yeah. I'll get straight into it. Yeah, if we can just bring up the slideshow. Geopal Africa is a driven pile contractor, as I said earlier, and we specialize in driven ductile iron as well as driving other sections, be that I-beams, C-sections, or H-sections. The latter more particularly used for PV support structures, being that a tilting or tracker system or just your general north-facing or sun-facing panels. Geopile was registered in 2004 as a deep foundations contractor. We are a level 3 triple BEE contributor. And yeah, we're part proudly of the Geo group of companies, which is really just a geotechnical group of companies that deals with investigations and foundation solutions in general. Okay, and because of the simple, fast, and safe installation methods of the ductile iron pile, on most sites we are rated #1 in safety, with almost no incidents to date and over 58,500 piles installed on one project. That was actually just over 55 kilometers of pile that was installed. Just moving forward. Our fast economical solution that we have is based on a standard 30-ton excavator fitted with a powerful hydraulic braking hammer. And this system was first developed in Europe and has over 35 years track record with more than 5 million linear meters of this pile installed around the world. Okay, just some typical applications for the pile, generally for vertical load carrying capacity, but as you can see, it is very easy to rake the piles up to 45 degrees or more. So they can also be used for slope stabilization, intersecting the slip circle and helping with lateral support. The pile is installed in the same method, but can work in two different ways, depending on the geological conditions at hand. The most used in South Africa is our end-bearing solution, where the pile is simply driven to refusal, practical refusal, onto bedrock. And the second is a skin friction pile. And all that takes is the addition of an oversized grouting shoe at the base of the pile and a concrete pump to deliver concrete around the annulus and therefore provide skin friction for load resistance. Okay, this is just a little sketch of the simple modular system that is Geopile. The pile sections are driven in continuously and until they hit bedrock or refusal. Here's a quick little look at what a wind turbine foundation looks like with ductile iron piles, particularly used in the sandy coastal areas over a very large foundation. But yeah, with the use of these piles, we found with experience that we can actually shrink the footprint of a wind turbine from around about 20 meters in diameter down to about 12 meters, and also reduce the thickness of that foundation. The graphic on the left-hand side is the most important piece of quality control measures that we take, and it's a visual representation of the time taken for the pile to penetrate the soil. You can see at the bottom, near 320 seconds per meter, the pile has reached basic refusal. And yeah, it's important to note that the pile is driven in with almost 3,000 kilonewtons per blow. And depending on the section, diameter and wall thickness, it takes between 500 and 1,000 kilonewtons safe working load. So that means that the pile is driven in with 3 to 6 times its working load. And if there is going to be any failures, it will happen during installation and not during the working life of the pile. To make this material incredibly shock resistant, it has very high levels of silica and carbon, and it also goes through an intensive heat treatment process. At the end of the day, it allows us to design piles for a working life of up to 100 years. That being because of the corrosion resistance of the actual ductile iron. They are manufactured in a factory to strict European technical approval and standards, and they are made from 100% recycled material. So that, in conjunction with the low concrete requirement for this pile, makes it incredibly environmentally friendly. Getting back to the socket connection, there you can see it's a geometrically coupled socket, spigot and socket joint that doesn't require any welding or splicing when you join the pile. It's simply down to the geometrics of the system and the force at which the pile is driven in. What happens is that the toe actually cold welds into the socket, forming a rigid bond that transfers all bending moments and compression. And then for any tensile loads, we install a suitably sized reinforcing bar, which goes the full depth of the pile to lock all of these joints together, even though tests have shown that they can take well over 20 tons of tension just with the socket with no concrete. Nino alluded to Kazoo, Solar One in Uppington, where we installed over 55,000 meters of this pile. We were averaging about 100 piles per day per rig. So the 55,000 meters was done in just over 8 months with all of our machines on site. There was very, very strict tolerances. What we actually offered here was an alternative solution because the postulated piling solution was a large diameter pile, and we replaced it with 4 smaller diameter piles with the threaded reinforcing bar concreted into the head of the pile within 3 millimeters of accuracy. So yeah, it was very important to be accurate on that side. We offered a full turnkey solution actually because it was an alternative solution, and that went with a lot of in-situ testing before we actually went to site to start the works. We were there on site for at least 5 weeks doing tests throughout the proposed area, and you can see we were able to achieve tensile loads of up to 8 tons without any pre-drilling or concrete, merely by driving the pile section into the ground. And this part of the Northern Cape is actually notorious for its abrasive concretes and harder granite gneiss, and the pile was able to socket in there, or self-socket on its own with no pre-drilling, which was a massive advantage for us and a big cost and time saver for the client. We also have done PV mounted structures on ductile iron piles, and this was for Dube Trade Port in Durban, just near the airport. We came up with the clamp solution to brace the PV panel purlins to our ductile iron piles, and yeah, it worked very well. There you can see just another close-up of the clamping method. All of these piles were installed within 2 weeks on site, and not driven to practical refusal, but driven to suit the tensile load required. Okay, just go back one, please. This is just another picture of the parabolic troughs that Nino was talking about earlier. We've quoted 58,000 piles, just over 110 linear meters installed. So yeah, it is a very fast system, and our client is very satisfied at the end of the day. Recently, we've also purchased a fleet of smaller pile driving machines, which is more suited towards PV. And because with the PV suppliers generally supplying the posts as well as the panels, it just makes sense to have this sort of machine that can easily install lip channels, I-beams or H-beams along any row. This project in particular wasn't too easy, and it wasn't too economical for the client because of the tough soil. So what was required was actually percussion pre-drilling, cement stabilization of that pre-drilled material, backfilling it, and then also concreting the top 300 mils of the hole to ensure that the pile was able to meet the tensile load. So not a very user-friendly system, quite a bit of admin involved, but at the end of the day, it was what was chosen and what was finished. So I think we'll just open the floor to questions. If anybody has, we'll just put a pin on that. Going back to Nino for his second part.
Yeah, just to round off and just to explain what the GCSEU unit actually does and can provide for our clients. It actually was formulated 5 years ago, 2015, but has been formalized, let's say, in 2018, and from the last 2 years we've been utilizing this as a special purpose vehicle, if you want to call it that. And basically, under the GCS Renewable Energy Unit, we can provide environmental studies, which involves environmental impact assessments, basic assessments also, and permitting and licensing for solar and wind farms, engineering desktop studies, topographic studies, GIS and VIA, I'll explain that a little bit later, hydrology and floodlines, intrusive ground investigations, or GI, which is my speciality, that's what I bring to the party, ram pile testing, which is the domain of Warwick, and Geopile, which is just explained also, construction planning reporting, structural engineering, and then I'll end off with this curious dilution and exclusion. I'll explain it when we get to it, but it's quite an interesting concept. It's a dilution or exclusion of our services to the renewable community. And then just to end off with a summary. Thanks, Leon. And that's just a pictorial showing the capabilities of the REU, GCS REU. And then just the interactions between geotechnical engineering and what the interactions between all of those, which can be applied to renewable energy developments, as structural engineering, transportation, construction, environmental, earthquake, hydraulic, mechanical, and plane geology. All of that is interrelated with geotechnical engineering and is relevant to renewable energy developments. The first one, environmental, is we have a very competent and large environmental unit within GCS, larger group of companies. And basically, the end result is not really our work, it's from the government. They've proposed these renewable energy development zones, REDs, and those are defined by nodes that have been linked into zones. And the purpose of these zones is to provide a relaxation of the environmental legislations required for renewable energy developments. So basically what it does is it creates a smoother transition to the overall development of these projects, which is great news. I mean, it decreases the time frame, basically. This is my specialty, engineering desktop studies, can be done at pre-feasibility level. All my engineering geological colleagues who are hopefully with us today will be familiar with this. It's a matrix of defined by 12 common geotechnical constraints, such as glacial soils, seepage, active soils, and 3 orders of severity on the top, as you can see there. What we've added is we've taken this original suggested by Partridge and other people, and we have augmented it with the CSIR Red Book, which provides respective cost implications concerned with each one of those constraints, which is very valuable in the early stages of a project. Topographic surveys, this is also very important. You'll see there the traditional methodologies that I grew up with, theodolites and dumpy levels, that has been superseded by technology, drone technology specifically. And the end result is the production of a topographic map, which is essential to aid in the bulk earthworks design for solar farm platforms. Since PV farms can cover thousands of hectares, these are very, very large areas that are affected. The geographic information systems and visual impact assessments, we can also offer this under the REU. And basically, it's important to collate all the information, topography, vegetation, geology. All of that can be layered and presented to the client in a layered fashion. And the visual impact assessments are very relevant to wind farms and CSP tower technology due to obviously the vertical impact. Those towers can be 200 meters high and can be seen for a great distance. And specifically for CSP towers, the blinding light that can be seen for kilometers from a CSP tower development is quite environmentally impactful, and that has to be assessed during the environmental assessment. Yeah, this photograph tells it all, really. The importance of definition and delineation of 1 in 50 and 1 in 100-year floodlines, so that this doesn't happen, because basically floodwater and renewables do not mix unless you're looking at hydroelectric power stations, obviously. We have a large and competent hydrogeology and water supply section in the larger GCS group of companies. And this is obviously required during construction. Any construction requires water. But luckily for the ram pile system, this requires no water at all, so there's no water demand whatsoever. But there is water required during maintenance after construction for the cleaning of the solar panels in remote areas. This is specifically important. The intrusive ground investigations, this is my specialty once again, as you can see there, test pitting on the top left. Bottom left is the probing portion of the site investigation, and then we get to the more expensive drilling phase of the investigations. And my engineering geological colleagues will know all about this. But we also use geophysics, not shown here, and maybe I'll adjust this for the another webinar. But geophysics can tie in all of these single investigation points all together to provide lateral continuity. The ram pile testing can be included under the REU, the GCS REU, also through Warwick and Geopile. And in my opinion, the most effective and environmentally friendly foundation methodology, specifically for the heliostats and the solar field applied to solar developments, but also to stabilize maybe even the large reinforced bases for wind turbines. This picture shows the whole construction or planning team, let's say, not sleeping because they're out of boredom, but because of peace of mind. This is the effect of a good, thorough construction planning report, which we can do whilst we're on site doing the site investigation. And basically, it provides so much information at a very early pre-feasibility stage. It can provide information on existing services, commercial construction materials, water availability or the lack thereof, access roads and trafficability to get to site, vegetation cover, power availability, obviously for construction requirements, and infrastructure and accommodation for construction personnel. Also, our foreign clients have been very, very appreciative of the construction planning report. Structural engineering, we do have structural engineers associated with us, and they get very excited by this picture of a labyrinth of rebar. This is required for mass foundations for wind turbines, and sometimes in the poorer soil areas along the coast, which is where wind turbine technology takes the fore. These can be supplemented by piles, which is obviously where Geopile come in again, with their expertise to counteract any of these overturning movements as shown below. And then a quick chat about dilution and exclusion. This is quite a dramatic photograph, but it shows basically, and it applies to all ground investigations that should be done for all structures built on the ground. And unfortunately, some developers like to cut corners to save money. I term that dilution. So they'll just pay just enough for what's required for a minimum amount of ground investigation. Or sometimes they don't even consider budgeting for a ground investigation, the cost of which can be less than even 0.1%, which is not a lot of money, but it is the first check that they get to write, and they want to obviously keep their money in order, and that's the exclusion part. And the consequences can be seen dramatically there on this wind turbine, just flipped over due to poor embedment, poor soil conditions, and knowledge of the soil conditions, which wasn't known at the time, and then a little cartoon showing what happens if you save money on soil tests before the Leaning Tower of Pisa became the Leaning Tower. And then in summary, just from a South African perspective, and I think South Africa is behind in global terms with renewable energy development, but it is getting better. South Africa's energy demand is 250 terawatt hours per year. And that's mostly been provided by coal in the past, but renewable energy is increasing rapidly. South Africa is blessed with 2,000 kilowatt hours per meter squared and 2,500 hours of sun per year. That's almost unbeatable globally. South Africa's average annual temperature rarely goes above, this is the average annual temperature, rarely goes above 25 degrees centigrade, which is the optimum for solar development. Anything above that, the efficiency drops significantly. South Africa has vast tracts of flat, undeveloped land, specifically in the Northern Cape, where most solar developments are taking place. South Africa has 3,000 kilometers of windy coastline, perfect for wind turbine technology. And there's a benefit of 3 to 5 times more jobs with renewable energy compared to the traditional fossil fuel technology, which is also localized. Coal technology is localized in the Eastern Mpumalanga area province, whereas wind and solar particularly, can be done all over South Africa, which provides employment, 3 to 5 times more employment all over South Africa. And then just a little send-off. I believe that the civil engineers and the civil engineering community are committed to clean and everlasting solutions for all humanity. And I think we can all agree to that.
Yeah, no, definitely.
Yeah.
Maybe just to simplify and go back to the pile load test or the pull-out test that we perform. What is the point, or what is the whole reason that we go to site and do this? And if you have 55,000 piles per site, every centimeter of pile length makes a difference. On that sort of scale, the savings can be quite large if you actually really investigate and economize your foundation solutions as much as possible. Like option number one, the best option is a driven pile without any concrete that can be used as the upright for the mounting structure for PV or CSP. Okay. Beyond that, the section, and as we know, the solar belt runs really along the Orange River, mainly in the Northern Cape, as such, with who's been developing it recently, and those areas are kind of notorious for rough concretes, granite gneiss, and maybe a little bit of Kalahari dune sand, wind-blown dune sand. So yeah, the driven pile would be the first choice. The second choice would be, or the second most economical, would be a pre-drilled hole with either with cement stabilized soil refilled or with just the percussed out material refilled back in the hole and the pile driven into that hole again. It's important to note that the hole should be slightly smaller than the pile section in order to generate some real skin friction out of that undisturbed soil. The third most economical would be a concrete stabilized soil with a small concrete cap, maybe 300 mils from the top, just to make sure you can meet that tensile load requirement. And then obviously the fourth and least economical is a pre-drilled hole filled with concrete and the pile section lowered into it. Yeah, now we also do lateral load tests, and generally this is just to check the lateral resistance of soil, so that if the soil can't provide laterally what we're looking for, then perhaps concrete may be required a certain depth from the top in order to stiffen up that pile so it can carry this load without the soil providing as much as potentially they thought. Okay, now we can go to the Q&A. I've got it here on a different screen. We've got a question from Jenna McCarthy. With VRA, what has been the experience and feedback from local communities if tensions are raised, and what is the best course of action?
Public awareness, obviously, in the EIA process, there'll be public participation, and all of those concerns will be raised, and then participation meetings will be held with the local community, so that those particular concerns can be raised. Mitigation of those, in terms of let's say a CSP tower technology, there's not a lot you can do. I mean, there's going to be a blinding light which can be seen for miles. With regard to other aspects, at the end of the day, the positives of the renewable energy should be looked at and outweighed against pollution created by coal technology.
Okay. I've got another one here from Mohammed Osman. He asks, what is the frequency of pull-out tests for a particular site? There are rules of thumb based on the size or the amount of kilowatts that you're looking at, or the hectares of the site, but it really comes down to the variation in the geology across the site. If the geology is uniform, you can get away with less tests. If there's massive variations in the geology, one would need to test each varying geological occurrence. Nino, do you have?
Yeah, and that's the importance of a good geotech investigation. If that's done correctly, then there will be a zonal map showing the facets and the different geotechnical constraints in plan. And then basically on there, we can do either 2 or 3 per facet and then design our testing accordingly.
No, that's it, exactly, yeah. Now, and just to reinforce what Nino said there, the first step should be a thorough geotech investigation before the piling testing starts on site. Because without that initial info, number one, the piles tests will become more expensive because of the intuitive nature that they would have to take on. As you find more info, you adjust the tests to suit. But if you have this info already, it makes life a lot easier and a lot cheaper for all parties involved. All right, another question from Jared McCarthy. He says, the development zones for renewable energy are mainly demarcated in the western provinces of the country. Does this leave the eastern part at a disadvantage in terms of transition and storage? I think it meant transmission and storage.
Yeah, sorry, the name again?
It's Jared.
Jared, hi Jared. Yeah, it does look like that, but that it covers most of the western portion of South Africa. But those are the areas most suited to solar, and certainly wind along the coast as well. So you're right. On the eastern side, I see there's not a lot of information for red zones, the REDZs. But that's purely because I think the inherent capabilities of the land, the climate, and the benefits will be found in the central and western portions of South Africa.
Yeah, perhaps I could even venture a guess. I mean, I'm talking under correction here, but potentially the amount of electricity produced in the eastern part of the country is already saturated, because of all the coal-fired power plants there. There's already enough generation capacity, so it's not really needed for renewables.
Yeah, you're quite right, Warwick. It's been designed to cover the areas except in Mpumalanga, basically, where the coal deposits are located.
All right, yeah, that's all for now. This podcast or this webinar will be available on YouTube to watch at a later stage. We're going to just leave an information page up here with our contact details. And if you guys have any questions, please feel free to email Nino or myself. We work together on a lot of projects, and please just feel free to contact us.